guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And before any of you guys say anything in the comments, this is not an upside down 8, it's just how the font is. So it's not an upside down 8. So we have 3 to the power of a squared is equal to 81. Now 81, well, this is what we want to do is we want to make these two bases the same. We have 3 and we have 81. And we want to change one of these bases so that they're the same as the other. Well, 3, it can't be simplified much more. So let's change 81, and 81, well, this is equal to 3 to the power of what? Well, 3 to the power of 3 is 27, so and 3 to the power of 4, well, that's 81. So x would be 4. So 81, I'm actually going to replace with 3 to the power of 4. So now we have 3 to the power of 4 is equal to 3 to the power of a squared. Now, because both of our bases here are the same, we know that our exponents here are the same as well, because if we have a to the power of x is equal to a to the power of y, this must mean that x is equal to y. So this means that a squared is equal to 4. So now we want to cancel out this power, so I'm actually going to take the square root, because remember, the square root is the opposite of the power. Now these two cancel out, and we are left with a is equal to plus or minus 2. Most people here would just say that the answer to this is 2, but it's actually positive or negative 2. So now this is our answer. Now I'm actually going to plug this in and check if it's right. So we have 3 to the power of 2 squared is equal to 81. 2 squared is 4, so we have 3 to the power of 4 is equal to 81. And 3 to the power of 4 is indeed 81. So we have 81 is equal to 81. And this is right. And the same thing for negative 2 squared. While taking the power of an even number on a negative number, we'll change it to positive, so this would be the same result. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n is equal to 2016. Now, by knowing this, we could actually decipher a couple things. Because this is positive, 2016 is positive, we know that m has to be greater than n. Because if m was negative, then this would actually be negative. And if n was greater than m, this would actually be negative 2016. So by knowing this, we could just say that m is equal to n plus k. K being a constant. So now if I subtract k on both sides, I get m minus k is equal to n. So now I'm actually going to replace m with I'm going to replace m with n plus k. So now we have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now this can also be written as 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 2016. And now if I factored out 2 to the power of n from this, I would get 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So now 2016, well, this is actually equal to 32 times 63. So now we have 2 to the power of n times 2 to the power of k minus 1 is equal to 32 times 63. And now 2 to the power of n, this is actually going to be an even number because 2 to the power of anything is going to be even. And 2 to the power of n minus 2 to the power of k minus 1, well, that's going to be odd. Now 32, well, that's an even number, so I'm going to write e for even, and 63 is odd. So meaning we could just say that 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So if 2 to the power of n is equal to 32, then n is equal to 5, because 2 to the power of 5 is equal to 32. And we have 2 to the power of k minus 1 equals 63. If we add 1 on both sides, we get 2 to the power of k is equal to 64, meaning k is equal to 6. So now if n is 5 and k is 6, well, we could simply plug these into this. M is equal to n plus k, and n plus k is 5 plus 6, which is 11. So m is equal to 11. So now these three are our values.